Hi, this is Miss Wiles, and today in this video we're going to be talking about linear systems. But to begin with, on the warm-up, we're going to review some solving strategies, some procedural things that we use whenever we solve inequalities. And if you're watching this at home, pause now and try to work these out and come back into the video to see how to work them. And we're going to look at number 1 first. We have an inequality, negative 7x is less than negative 9x plus 14. This is solved just like a linear equation if there were an equal sign. Inequalities are solved just like equations, except when you have to either multiply or divide by a negative number. Recall that you would have to switch the sign. You'd have to flip the sign. And that only happens if you have to multiply or divide by a negative number. So when we look at this, we see that we have x's on both sides of the equation. And our first step, after we've determined that there are no like terms on both sides of the equation to combine, is to use inverse operations to isolate the variable. And we do that by beginning to rearrange our equation so that our x's are on one side and our constants are on the other. So the most efficient way for this to happen is to add 9x to both sides of the inequality so that this negative 9x will cancel out. On the left-hand side, we have negative 7x plus 9x, and that gives us 2x, and that is less than 14. Then our next step is to divide by 2. And when we divide by 2, we have x is less than 7. And that is solving that inequality. Now you should try number 2. Number 2, the inequality is 2/5 x is greater than or equal to negative 6. Now at the beginning of the course, we went over all the properties of numbers so that we would know what to do when we saw something like this. Like when if you recall, if you had these properties of numbers that when you multiply certain things, you would get 1. And the reciprocal, the inverse property says if I want to get 1 from that 2/5, if I want to get rid of it, I'm not going to divide by 2/5 like I divided by 2 over here, because that doesn't make a lot of sense. And to divide by 2, well, it does make sense, but it's not the way to finish it out, because when you divide by 2/5, you actually multiply by 5/2. Anytime you divide by a fraction, you're actually multiplying by its inverse. So you need to multiply both sides of this inequality by 5/2. When you multiply by 5/2, the 5/2 times 2/5 is 10 over 10, which is 1. And that's why we do that. And on the right-hand side of the equation, we would have negative 6 times 5/2. You can do that with your handy-dandy calculator, or you can say, oh, I remember how to multiply fractions. It's negative 6 over 1 times 5 over 2, and we multiply straight across. We multiply the numerator, negative 6 times 5 is negative 30, and the denominator is 1 times 2, which is 2, and when we simplify that, we get negative 15. We did not have to change the sign at all because we did not multiply or divide by a negative number. Now let's look at number 3. Questions about number 2? It really shouldn't matter if it's a grade or not, because you should be doing it anyway. But yes, there are a couple of questions on here that you have to do tonight after watching a video, and this is something that will be turned in. If you want to see what's being graded, look right after the warm-up, and on the first slide that's not part of the warm-up, it tells you what you're going to be doing, your product. Oh, there's going to be inequalities and equalities, and yeah, tough stuff. Tough stuff this week, but you can do it. Number 3 says to solve this inequality, you have the absolute value of 3a minus 2 is less than 4. Then graph the solution set. Now, something that you have to remember about absolute value is what is absolute value. And absolute value is talking about the distance that a quantity is from 0 on the number line. So, for example, if you go way back, the absolute value of 4 is 4. And the absolute value of negative 4 is also 4. And that's something that you have to just know about absolute values, is that this is the property of absolute values. It'll always be positive. Well, if this is the case, if the absolute value of 4 is 4 and the absolute value of negative 4 is 4, then we really have two inequalities here. We have two inequalities. The first inequality will happen if 3a minus 2 is less than 4. The second inequality will happen if negative 3a minus 2 is less than 4. So we have to solve both. There are two inequalities for us to solve. And then it becomes a two-step process. 3a minus 2 is less than 4. Then actually with the second one, it's going to be more than 2. We add 2 to both sides. Most of you still need to see that. Then this cancels out, and we have 3a on the left-hand side is less than 6. We divide by 3, and a is less than 2. For the other equation, we have more to do because we had to take the opposite. Since 3a minus 2 could be a value, the negative of that whole thing would also give me a correct response for this inequality. When I have a negative outside the parentheses, remember the distributive property, I have to distribute it to both terms on the inside of the parentheses. So that negative 3a minus 2 becomes negative 3a plus 2. And that's less than 4. Then I need to subtract 2 from both sides of the equation, or inequality. These cancel out, and I have negative 3a is less than 2. My last step is to divide by negative 3. When I divide by negative 3, because I'm dividing by a negative, I have to switch the sign and say that a is greater than negative 2/3. To graph this solution set, all I need is a number line. And I need a number line that is long enough to handle a is less than 2 or a is greater than negative 2/3. So the good place to start is with 0, and then I go 1 and 2. And then back below the 0, I go negative 1 and negative 2. Well, certainly to graph this, a is less than 2, I would put an open circle on the 2. And for a to be less than 2, it's going to be here. It's not going to be a closed circle. A closed circle on a number line happens when you have like less than or equal to, when it has the equal part to it, or greater than or equal to. If your inequality symbol doesn't have the equal part to it, then you don't put a closed circle. A is greater than negative 2/3. You have to estimate where that is. Where would negative 2/3 be on this line? And it would be somewhere between 0 and negative 1. And it would be closer to negative 1. So you would put a circle about there. If you put it closer to the 0, that wouldn't quite be right. You got to make it logical. But you're still estimating, but a good estimate. And a has to be greater than negative 2/3 or less than 2. And so this is what your solution set will look like. And we'll go on to number 4. In number 4, you have a word problem. Write an inequality and then solve the following. 10 less than 5 times a number is greater than 10. So taking these words and changing it into algebra is something that you need to have that skill for. When you see something like a number in a word sentence that has to do with algebra, that means you don't know what the number is. So it's the variable. We want 10 less than 5 times a number. Now, 5 times a number is 5x. And 10 less than 5 times a number is minus 10. And then the words is greater than looks like that, because that's what that symbol means, is greater than 10. And now we need to solve. And when we solve this, our first step is to do what? Add 10. And we have 5x is greater than 20. And our next step is divide by 5.
You get 4.
And we have x is greater than 4. Very nice. Now let's look at number 5. Before we go on with number 5, the most common mistake on number 4 would be to do 10 minus 5x. But that is not 10 less than 5 times a number. That is 5 times a number less than 10. The less than means that it's going to come after this, after whatever it's following in the words. With the words, it'll come first, but with the algebra, with the math, it comes after. So now we'll go on to number 5. Lori had a quarter and some nickels in her pocket, but she had less than 80 cents. What is the greatest number of nickels she could have? Well, what do we know about this problem? If we read it again, just kind of go through it again. Lori had a quarter. How much is a quarter? 25 cents. So she's got that. She's got a quarter. And she's got some nickels. We don't know how many yet. That's what we're going to figure out. She's got some nickels. Well, how much is a nickel worth?
5 cents.
A nickel is worth 5 cents, and that looks like 0.05. And that's what it looks like in numbers. We don't put 5 with the cents out after it, but she has some nickels. The X is some. She has some nickels. We don't know how many, but whatever she has to be less than 80 cents. So she could have 1, 2, 3. We're going to find out what she could have. Our first step should be to subtract that quarter from the 80 cents because we know she's already got that. So when we subtract that quarter, we have 0.05x is less than 0.55. Now we need to divide that 0.55 by 0.05. And to do that, if we weren't using a calculator, which we do need to work on those skills, we'd move that decimal 2 places. The decimal is here in my answer. And then 5 goes into 5 one time. Then 5 goes into 5 one more time. So we have 11. And so x has to be less than 11. Could she have 11 nickels in her pocket?
Yes.
No, because it says it had to be less than 80 cents. If it said that it could be less than or equal to 80 cents, then she could have 11. But she could have 10 or 9 or 8 or 7 or 6 or 5 or 4 or 3 or 2 or 1 or even 0. Because all of those values will give us a quantity of money in her pocket that's less than 80 cents. And she's going to be asking somebody to borrow some money for lunch. And then we'll do number 6, and that'll be it for the warm-up. Number 6, which inequality does this graph represent? And you have this graph over here. It's got a dotted line, and then it's got a shaded area up above it. Now that shaded area up above it doesn't necessarily mean that you should go to these greater than signs first. It doesn't necessarily mean that. The procedure that we'll use to go over this problem is what you should use with these types of problems. Now, what we know about the line or the dotted line that you see is that values on that dotted line would make these equal. It would make these equations equal. The only reason that it's dotted is because the equal sign is not part of our answer choices. So if we take a point that we know is on this dotted line and substitute it back into the equations, the inequalities that we have over there, they're going to make some of them work and some of them not. So what's a point on this dotted line that you know is an actual valid point that would be on that dotted line? This 1. And that point is 0, 1. Now the x is 0 and the y is 1. For these 4 equations, these values for x and y are not all going to work. So we're going to check it and see which ones do. But we're going to use, when we check for the line, when we're checking the line, this will be the first thing we do, is check the line. When we check the line, we don't worry so much about the less than or greater than part, only the equal part, even though it's not there. So when we check A, we do 3 times 0 minus 1, and I wrote y. I guess you know why I wrote y, because it's part of the problem over there. And there we go. All right, minus 1, is that equal to 1? Well, when we do 3 times 0 minus 1, we get negative 1, and that's not equal to 1, and so A is not the correct answer. If we look at B, we have negative 3 times 0 plus 1. Is that equal to 1? Negative 3 times 0 is 0, and then the 1 equals 1, so it might be B. Maybe. Put a little check, because it might be. When we check C, we do 2 times 0 minus 1. Does that equal 3? We have 2 times 0, which is 0. Does negative 1 equal 3? No. So C can't be it. And then D, we have negative 2 times 0 plus 1. Does that equal 1? Negative 2 times 0 is 0. That 1 does equal 1, and so it might be D. So it's either negative 3x plus y is greater than 1, or negative 2x plus y is less than 1. Now those are very different. So we can look at another thing and see, okay, do we have another point that we could check? Can you see another point on that line that you could check that actually goes through? What about this one? What about negative 1, 2? I mean, negative 1, negative 2. What about that point? What if we check that? If we check it for, we don't have to check A and C anymore. We can check B. Negative 3 times negative 1 plus negative 2. Is that equal to 1? Well, negative 3 times negative 1 is 3, and then plus negative 2 does equal 1. And so we're like, okay, B is really looking good. It's got 2 things going for it. Let's see what else is going on with D. When we finish up checking D, we still want to use this negative 1, negative 2. Negative 2 times negative 1 plus negative 2. Does that equal 1? Well, negative 2 times negative 1 is 2. And then when we add negative 2 to it, what do we get? 0. And 0 does not equal 1. And it can't be D either. So we're using some checks to see what it is. Now you may say, well, that's a whole lot. And yeah, it's a little bit. There are other ways to do it. The other way that you can do it, if you've got your calculator, is to change each one of these equations, inequalities, so that you have y isolated. And that's going to be a lot of work too. You might as well get used to a lot of work in your high school math courses, because every problem takes a lot of work. And so you have to put all those skills together to be able to work with that. We're not going to go through solving each one of these for y, but you definitely could do that, just like we did the other equations to isolate the variable. And that's all I have to say about that.